so Doctor, you've been with Ares Corporation for how many years?
Just 2.5 after 32 years in the federal government.
Wow, doing what?
All sorts of really fun stuff. 12 years at Federal Aviation Administration doing flight test work, acoustics and vibration. And then 20 years working for NASA in a variety of jobs. I was Titan IV program manager. I was director of Review and Assessment Division in Office of Spaceflight. Worked on the shuttle, worked on the station, and just had a lot of fun. I feel very blessed by the time I had in government. I also, during the last 10 years working for NASA, because we were learning so much when we went out and did reviews of programs and projects, some that worked, some that didn't work. It was back in 1998 that, gee whiz, maybe there's a way we can use the web to share stories broadly across our mixed, geographically dispersed community. And that's when we started building PBMA, which is still running today. It's approaching its 10th year with, I believe, close to 20,000 users in over 700 individual communities of practice.
Wow.
Yeah.
So clearly you've got a lot of experience. I was actually on Facebook earlier posting some comments, and I wrote on there that I'm in a conference full of rocket scientists, and I'm the dumbest person in the room, and it's so cool. So anyways, everybody put your hands together. Dr. Newman.
Okay, I really like those charts that I showed, that if people are tilting their heads, that means that they are indeed listening and interested. So I want you all to try this now. And the chart didn't say how far, because maybe it's 10 to 15 degrees, but if you go too far, that means you're falling asleep. So the goal I'm setting for myself is to try to get a room full of tilted head people. Okay, the charts. Trying to set up. Okay. Yeah. Okay. While that is getting queued up, in fact, it's a good deal because I can speak from my notes that are really not prepared per se. Okay, I have talked a lot about knowledge management and taught KM at George Washington University. And I have had the privilege to work with a number of folks in this room, including Jay Leibowitz. In fact, out of chapter 12, I think, in his book, right. And I've worked for years with my colleague up here, Gene Holm. In fact, we were welded together on 9/11/2001. I was holding the first NASA Community of Practice workshop. We were out at a location in Falls Church, Virginia at CSC. And we started promptly at 8, and probably, gosh, I'm not exactly sure of the time, but 20 minutes into the meeting, somebody came into the room looking stricken. We switched the wall-to-wall screen to the news, and regrettably, we all watched the Twin Towers fall before it. So it's sort of a sad story, but it's certainly a shared, a shared point in time that I can go back to and say, yeah, indeed, we were beginning to try to figure out this KM business back in 2001. Okay, the first thing I want to say about KM and succeeding with KM is we don't talk about KM. I managed this program, and I didn't say knowledge management system, I said knowledge management program. For the last 10 years, I was a civil servant. I am now a contractor, and I'm working for someone else named Dave Lingle, who is the Chief Knowledge and Risk Manager for the Space Exploration Mission Directorate. The cool part is I can still work in KM, and I'm going to be telling you a little bit about what has worked for Dave and, pardon me, and I'll be summarizing those things that work for me. First thing, do not walk into a room with a NASA program project manager and say, I'm here to talk about knowledge management. Okay. Immediately, they're going to start looking for this. And, you know, the eyes will roll up and they'll try to find some junior person to come talk to you. Rather, say, I'm here to talk about doing work. Okay, we built our church, if you will, on the rock of work. Okay, it's about helping people work more effectively, more efficiently. And it's a simple story, and we're sticking to it. Okay, it links to this. Pardon me. To links to the second main point I want to make, and I am totally a KM bottoms-up person. What you saw, the work done by Randy Atkins with Air Force Knowledge Now, totally bottoms-up. We'll provide IT infrastructure, come in and use it to accomplish your work, rather than a top-down CIO-directed, okay? The story I have here is very, very strongly oriented on work as a central theme. Technology is strictly enabling. In fact, I don't believe that the Chief Knowledge Officer should be within the office of, within the office of CIO. And I have found that those KM initiatives that have succeed because they're sponsored by a critical work process owner, okay? And where there's very, very clear return on investment to the organization. But I want to go back 2 other steps. For it to succeed, there's got to be personal return on investment. Okay, it means that if I got to screw around and call this number to get my password updated, you know, once every 30 days to get into the system, it damn well better be a system that enables me to do my work more effectively, okay? People are too busy to screw around with gadgets. And I'll say a few words about Twitters and tweets and blogs as well. I fundamentally do not believe, and hey, I am really a technology early adapter, but I do not believe the culture at NASA will sometime in the next 10 years really embrace those technologies as something to accomplish work. And I'm going to explain why. But first, there's got to be a personal return on investment. Then there's got to be ROI for the team, and then there's got to be ROI for the organization. And it all links back to doing work. Okay, 2 cases that I've had in 10 years that have succeeded hugely. In fact, we received the 2003 eGov Pioneer Award for the work we did on PBMA. And I'm still trying to figure this out, but sometimes I think KM is an abstraction that does not exist unless it's paired with a critical business process. Okay, then it lives. Okay, I observed at least 6 separate KM top-down things that said, okay, here, we now have this technology. Set up your community of practice and populate it with data. We've heard 2 or 3 people talk today about, gee whiz, that doesn't work. Okay, And that's certainly my experience, because there's no ROI. You know, it's tangentially related to doing work. It's not doing work. Okay, so the first point is pair it with a critical business process. The thing I did in 1999 was pair it with safety and mission assurance that is across all NASA facilities, programs, projects, activities. Okay, so I had a built-in infrastructure. Okay, Dave Lingle has paired KM with risk management. And depending who you talk to, people will tell you that program project management is risk management. I mean, that is what you do in your program or project management. So obviously, he has paired this again with a critical business process and has had great success. So a few other points. The first one is concerning the fact that, and we've heard a lot of discussion about the struggle and the challenges. The thing I think about when I think about KN is a deer hide being stretched and pulled, you know, 10, 12, 15 directions at once. And the key that about a year and a half after we had begun to stand up our community of practice structure, we recognized that we really had to engage with critical stakeholders. Okay, in parlance of NASA Codex, these are security people. Okay, they're not IT security people. We had to work closely with them on ITAR export control, the color of information. We, of course, had to work with people in the CIO's office, people in human capital. When we tried to stand up, as I said this morning, a system so people could find experts, people had a huge problem with the notion that Jay's an expert. You know, it's like, who said Jay's an expert? And does that mean he'll get a promotion before me? And then, and on and on and on. I mean, we have 15 people telling us we couldn't do what we wanted to do in terms of simply providing a mechanism for people to find an expert on composite overwrap pressure vessels. Okay? So we had to engage and become friends with the people who could stop us in human capital. The people at NASA called external affairs. They're the people who work with the State Department on ITAR export control. And basically stuff that people who are not U.S. citizens, folks who are not U.S. citizens cannot see the data. We spent a great deal of time and heat dealing with politics, rice bowl politics. You're looking at my cheese. I'm the CIO. Why are you standing up, a system for people to collaborate? And so, pardon me, the problems that we dealt with 7, 8, 9 years ago, many of these have now sort of been resolved. But the point is, it's critically important to engage with stakeholders very, very early on. And I mentioned security, recognizing that a program that's successful has got to have a very private dimension as well as public. In fact, I was standing out here gazing at the ocean, chatting with Gene Holm here a few minutes ago, talking about the number of fences. I mean, they're 1, they're 2, they're 3, they're 4, they're 5 or more domains where stuff resides. And if your program is going pardon me, programs can be successful, it's vitally important to build that into your structure and architecture. Finally, before I go to today's slides, I want to say a few words about what I call the dark side, the dark side of KBM. the first point, and I've done training at Kennedy Space Center twice, 3 times at Johnson Space Center, down at Marshall, at headquarters. The number one problem people have is time. It's time. I think somebody else said, well, yeah, I mean, you know, this is great, Twitters and blogs and tweets and wikis and COPs, but, you know, they're only 24 hours. Only 24 hours in the day. And the number one thing people can't do, and frankly, that's one of the big selling things with the way that we're rolling out wikis, is it allows people who don't have time to work in an asynchronous fashion. Okay, we're struggling to find a solution to not enough time. People are constantly in telecons, constantly in boards, constantly in panels, and frankly, this is rolling into a bit of the content. About a year ago, the light bulb went off when I was standing up beside in Wikipedia. And I said, gee whiz, this is really neat. You know, it requires me to have a narrative, a story supported by data. Gee, that's novel. That's fundamentally how people in the aerospace world work. Okay, you go to a board, to a panel, configuration control board, change board, safety review panel, you present a story supported with data. The real power with the wiki is it documents, it provides a built-in trail of breadcrumbs. LinkedIn providing all the data to support your story. And that's one reason why we figured out that, gee whiz, the wiki is a natural tool for people who work in this fashion. So, final point about the dark side. I picked this up down at a briefing was doing down at Kennedy Space Center, where somebody said, you know, just struggling with all the portals and portlets and wikis and COPs, and said, I have fragmented web presence. Okay, and again, that is truly a problem that we're all facing. This group, Ground Ops down at Kennedy, was required by the center director to have a portlet. They were required by the program project, which is at Johnson Space Center, to have a portlet. They had wikis, they had communities of practice, and they were struggling. All they wanted to do was work. Okay, so it's vitally important, given this dynamic whirlwind, fun technology blizzard. I'm probably mixing my metaphors here, but to sort out those things that help you accomplish work. And so if I can keep the story going here, several things that we're doing right now with Dave Linville and the folks in Space Mission Director is to make certain that we have a balanced program. Okay, and by that, okay, again, I'm not saying knowledge management system. I'm saying balanced program, a balanced knowledge management program that has a mixture of, and I'm going to show you in a second, a cartoon that is powerful because it captures all of it. It's a Far Side comic, and it's perhaps my favorite. And really, maybe I should just leave that up and just go sit down, because it really captures the whole thing. But the theme of thinking about how people do work, and I go back to a quote from Professor Mark Adelson at George Mason University, and I tie a lot of things to this very, very simple concept that work takes place in conversation. Okay? Work takes place in conversation. And I mean a full, pardon, with the three things somebody had on the chart. The words, body language, and the way it's said, passion. And I totally agree with Professor Adelson. Okay. So I'm sure that there are many in this room familiar with work of Steve Denning, storytelling. I mean, this guy has a third career on storytelling. You know, his whole thing is, if you want to succeed, organizations will learn how to tell a good story. It links right to the idea of conversation. It links to the idea of lessons learned, because we're talking about how do you convey or transfer lessons learned, okay? And I think we'll all agree that we've not been wired to go to some cumbersome database and ferret and do some arcane search and then get some sort of fragmented story. Okay, I mean it's not even close to being able to sit down with somebody who can tell the story and share the lesson. So, okay, it may take you a second to see everything going on here, but this guy has a, it looks like a lizard, okay? And he's just basically holding it over the fire with his bare hand, okay? Then the nerd over here, Zod, has technology, okay? This guy's got his on a stick, and pardon. The reason I like this is because it's got the campfire. You know, I think we can all agree that if you go back, what, 10,000, 20,000 years of human history, that most of the lessons learned, best practices, were probably shared around a campfire. Okay, and it's cool, it's really neat that we've got all this technology, but vitally important, we're going to work effectively to keep in mind that you've got to blend the campfire with technology. Okay, I'm not going to belabor this chart. It just simply describes various ways that the flow of this pitch is a bit disjointed. Dave had built this as basically a subset of a larger briefing focused specifically on the lessons learned. So you'll have to bear with me a little bit. Okay, so I think you're all very familiar with these various ways to transfer knowledge. And we're going to morph into something that I really credit Dave Lengel with providing an innovation in knowledge management and knowledge transfer. We were doing video nuggets on PBMA back in 2001. Dave has taken it to the next level. We just saw a pitch by a gentleman from Tribune about how they were using video to capture the wealth of knowledge from folks retiring. But watch what Dave has done here. Taking work, taking risk management, and knitting it together with video. If you look at a risk management database for a major program or project like NASA's Constellation program, okay, it's got the Ares 1X booster system that you saw on the cover. It's got the Orion spacecraft. This is a system that will replace Space Shuttle, okay? And if you go in and look at the risk records, what you're really looking at is a real-time snapshot of systems engineering taking place. Okay, these are real problems that people are working and trying to address. And so Dave has used the risk records within the ARM and IRMA risk management databases to queue up the knowledge content that he then delivers by way of video. very, very, very focused video. In fact, flying out here, I was going over some clips from a KBR, stands for Knowledge-Based Risk, which is a video, and pardon me, that I'll show in one or two slides. But the philosophy here is to cue the knowledge management with risk management to make it relevant to the problems you're trying to solve as you do work. So again, very, very focused on doing work. And so Dave's taken a continuous risk management product or process that generates the risk records. The data provides a queuing function or a lookout. You probably can't see it, but there's somebody on the bridge here. We're very, very acutely aware of the time constraint. Extremely, extremely concerned about this. And the risks in many cases are thought to be knowledge gaps. Okay, and I'm going to show you in the next chart the infrastructure that supports, well, okay, it's further on. I said the flow was a little messed up. Let me come back to the process map. This is something we found extremely useful in knowledge management, and it's called process mapping. And it's a variant of an org chart with colored lines that show the flow of critical information. We have boxes numerically indexed that show roles and responsibility. In fact, on the space shuttle return to flight, the assurance process map was literally 15 layers. Okay, and you find yourself with this kind of a challenge in a big, complex organization doing mission-critical activity. But the key here is that Dave has an infrastructure that he is able to leverage to get, pardon, to accomplish vertical as well as horizontal. Okay, it's hierarchical, but it's also has a very, very critically important horizontal communication piece of it. Okay, the knowledge-based risk is a risk record with associated knowledge bundle. Okay, knowledge artifacts. Basically, focused video. It's got documents. It's got PDFs. It's got drawings. It's got failures associated with that. It has a rich set of content associated with the KBR. Let me jump back up. Okay. The program, Dave's program, has these 6 pieces. The first one is continuous risk management. Okay, practice number 2 relates to doing work. It relates to your work process. We have something built in. It's not part of this pitch called Process 2.0. And it's all about taking your work process to the next level. And we've got something called Rapid BPA, Rapid Business Process Analysis, built into Process 2.0. And it's all about refining your knowledge of your own work process. Because before you bring in the IT tools, before you stand up a wiki, before you stand up a COP, we require, in fact, we've done training on this thing we call Process 2.0. And it's simply get ready to allow the technology to help you do work. Okay, the third one is, I chatted a bit about, and again, that's the knowledge-based risk. Fourth one is web-enabled teams, okay? You'll see, I didn't say community of practice, I didn't say wiki. I mean all different ways of collaborating using the web. With Dave in particular, he has a mixture of, he's using probably several hundred PDMA communities of practice. He stood up over 350, I think approaching 400 separate wiki sites supporting design, development, and test of Constellation. 5 is forums, brown bags, cafes. Who here has participated in a knowledge cafe? Okay, I mean, they are very, 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 very powerful tools. And then finally, number 6 is case studies. And these, we're working right now on space station design, test, and verification case studies. Things that work, things that didn't work. Dealing with issues such as how do you do tests like you fly, tests and verification on pieces that are arriving, spread out over time, spread out, across the world. But building case studies that again are cued by the risks. So this whole program starts with a risk record and then provides a variety of products and services to help people solve those risks, deal with those problems, accomplish work. And so, being extraordinarily relevant has been, a key to the success, sir.
Do you apply the same concept of risk to your people as well? And if you do, where does it fit in here?
I'm sorry, say again?
Do you apply risk to your skills and capabilities of your people?
Hugely. A major, major, major transition risk from the space shuttle to Constellation is human capital. And in fact, we are building a section in a system I'll talk about later called Riskapedia, specifically to deal with risk associated with human capital management.
Does that fit in any of these 6 areas?
Well, people are involved literally in all of these, but the specific risks show up in the top one, and in con will show up here. There are teams that are working a variety of transition human capital issues. So I mean, it probably shows up in all of them. Okay. So let me see. Okay, this is Risk Management 101 for those of you who have not been exposed to formal process of risk management. But again, Dave starts here. He springs upward from the risk records. And he uses the protocol that is defined in a variety of different NASA documents where you state something, for example, given the possibility that Keo may not come to dinner, there's a possibility that Jay may get stuck with Phil. Okay, or that's a very simple case of the protocol. But it's formal. There's actually training on this to get people to very crisply define the set of conditions or actions that may lead them to some sort of adverse action. The risk is then evaluated from the standpoint of safety, technical performance, cost, and schedule. And it's really a separate brief, but it's a very, very important business process that helps queue up KBRs. Okay, this graphic right here, I think comes as close as possible to capturing, I guess, the theme that we found to be extremely successful. And okay, the big wheel is work, okay, and that is your work, okay, and your work is not the same as hers or his, okay. It could be managing, human capital. It could be designing a composite overwrapped pressure vessel. It could be, doing safety, system safety hazard analysis. It could be providing communication to folks in Congress. It is your work. And that's why, again, we start with the business process analysis. And then you've got KM. Here you've got Dave's paradigm, which is risk management. The paradigm that I had great success was safety and mission assurance, quality. But it could be some other critical business process. But if you start with work, people are not going to tune you out, okay? Okay, this simply shows the growth in KBRs over time. They're up with 300 some KBRs. This simply shows that there's been a lot of cross-linking within all these databases. You've got the ARM and IRMA risk management databases. You can click and get the KBRs that actually live in a portal environment. There are also links to the KBRs from the wiki. So we've got all these various tools knitted together.
Is this an in-house grown risk tool?
Pardon me?
Is it in-house grown risk tool?
No, they're both COTS products. You know, ARM stands for Active Risk Manager, and IRMA, somebody help me out. We can probably guess, you know, integrated risk, you know, analysis management system. And basically headquarters ESMD uses ARM. Langley, I think, uses ARM. Johnson Space Center uses IRMA. I think Marshall also uses ARM. So we've tried hard to get folks all to use the same system. That's another story. This shot shows a typical KBR, and here you've got Mr. Ed Statham talking about specification of design tolerances in performing systems engineering. And you then have related knowledge bundles, related content, and of course it's 508 compliant, so you get a full text transcript. And if you were able to scroll down, you'd also see the specific risk records that are being informed by this. Gee whiz, we had this problem back in 2002, and here's how we addressed it. Okay, these, you probably can't read all of these, but they're very, very broad-based problems that folks are struggling with. The first one is acoustic levels inside the spacecraft. Okay, the new Ares 1X launch vehicle is basically an extended space shuttle solid rocket motor, and tremendous amount of thrust, and it has led to a much higher vibroacoustic environment, which frankly is still being worked. Second one, you know, building redundancy in a reliable system. Down here, you've got corrosion problems from the orbiter. We're very, very, very actively trying to harvest lessons learned from the shuttle and station program to inform this new space system called Ares Orion. Yeah.
Can you talk a little bit about that, how you're taking these and making sure that they actually do get transferred to Orion?
The 6 processes that we have laid out here are all designed to convey that. In fact, when we complete a KBR, it is sent to every single member of the program and project, thousands of people, by Doug Cook. Okay, again, in comes leadership, which is, you know, part of the critical mix to achieve success. So the very top person in the program basically sends out a 3-paragraph email and talks about how important it is, and go to this link and read it today. So
How can you make sure people don't get what they're looking for?
no way. I mean, you know, there's no technology I'm aware of that will keep somebody from sticking their head in the sand. You know, but there are a variety of other activities. There might be a knowledge sharing session on composite override pressure vessels to complement the KBR. There might be a wiki training activity that uses that as the case. So it's not a one-shot deal. It's truly a knowledge management, knowledge transfer program, dynamically informed by today's problems. And to me, that really is something. Oh yeah, and of course, I'm sure folks in the room may or may not be aware of the chemistry problems, corrosion problems, pedigree, COPD, eco-sensors. So the forums and workshops, Dave has quarterly workshops, very well attended, and different theme each time. And in fact, we were out at Lockheed Martin in Denver for a test and verification training course, a 2-day course for all those people on that wiring diagram, because the program is dealing with test and verification issues. So Dave's also working very closely with DAU, and there is a program management toolkit course that he's got probably 70 people signed up for, and they're taking right now. So there is very aggressive program of activities designed to promote the conversation that will accomplish the transfer of lessons learned. Right here is Bo Beamick, who I think is with Boeing now, but I thought he started out at Rocketdyne, maybe. But he did a fabulous briefing at Gates Forum down at Johnson Space Center, and his closing remarks were something to the effect that the biggest danger is arrogance. The biggest danger is that you think you know more than you know. And very, very powerful. Let's see. Oh yeah, the case studies have been very, very interesting. Wish I had more time to show you the super lightweight tank. It dealt with a very critical moment in the life of the space shuttle program, where if they were going to be able to launch to 51.6 degree orbital inclination, they needed more lift, more thrust. And why we needed that orbit was related to a vast array of topics, including the need to partner with the Russians, the need to be able to accommodate Russian launch sites, so it was critical that the space shuttle program drop about 10,000 pounds, and most of it came out of the external tank. And it basically meant moving to a new material called 2195 aluminum lead. But my gosh, this is a redesign. It's a new material. There were so many problems that the program encountered. They succeeded, but it's a fabulous case study. And the way that it was verified and tested without a flight test. I mean, really, the first full-up flight test was when it flew with a crew of, I think, 6. And so a very, very, very rich case. And relatively recently, I mean, we've been struggling trying to get lessons learned from folks in the Apollo program. And I think we all know why. I mean, we're just getting older and older. So this was terrific. And we had video of people at 5 levels, 4 levels. 5 is planned. Brian O'Connor was the Space Shuttle Program Director in Washington. He had one view of managing the list. The second one was Brewster Shaw, who was the Space Shuttle Program Manager in Houston. Third was Parker Counts, who was the External Tank Manager. 4 was the Chief Engineer on the External Tank. And within this case, it's amazing to look at the different perspectives of what people were worried about. And so it's the kind of case study, again, that we're working to develop. Right now, we're working on a case study on space station. And the course is very, very, very interactive, where data is presented, and then in a small group, people discuss, and propose control and mitigation strategies for a given risk. And so it then has the rest of the story. Okay, this is how the program actually controlled and mitigated the risk. So it's been very, very, very successful case study paradigm that we evolved, and it's also available online. And here is Parker Counts talking about, you know, the video and the challenge that he dealt with. Okay, this chart sort of brings it all together, and I like the balance of this chart. In the upper part, you've got technology stuff, and in the lower half, you've got people talking with each other stuff. And so, and of course, the idea, again, work is the central theme. If you stick to that, you'll succeed with KM. Okay, finally, I think I'm okay time-wise here. We are building a wiki-based application. It could be deployed in a portal, but we really want to leverage Web 2.0 types of involvement, co-authoring, and bringing in a broad range of subject matter experts. It's called Riskapedia, and it's designed to provide folks a place where they can quickly navigate to get ideas on risk identification, and then going into the evaluation and assessment of risks, and then, most critically, ways to control and mitigate those risks. And of course, here it is indeed linked to PBMA video nuggets, it's linked to KBRs, it's got knowledge bundles, it has co-authored narratives by subject matter experts, and it's pretty cool. Let's see. Oh yes, the 10 top most important keys to success to this point. Number one, maintain focus on enabling the accomplishment of work. Okay, I think that's the 9th time I've said that. Hopefully. Second is to link KM with some critical business process of your organization. Guaranteed to work. Third is to use risks as a cueing function to ensure that you're strategically aligned. Okay? Strategic alignment, I mean, like Twitter, why are you twittering? Blogging, why are you blogging? I mean, you're built-in strategic alignment, built in, okay? And that means you will have a champion, you will have a budget, okay? Because, gee, you know, it's obvious, this helps us do work, okay? Fourth point, learning through conversation, you know, Mark Adelson. Point number 5, time, respect, recognition that time is the most, it's funny, I haven't really figured out yet exactly how to articulate it, but for KM to exceed hugely within an organization, it has gotta save people time. It's got to provide things related to time, such as the ability to work together on a document asynchronously. The next point is use some sort of built-in network or infrastructure within your organization. You certainly want to try to see if you can leverage that. use existing tool functionality. Well, it's sort of the COTS, make-buy decision. Probably wouldn't be in my top 10. Most of these are. Recognize that collaboration is a resource multiplier. Again, and it's a hard sell sometimes where I've got to convince Amanda Smith that she needs to spend 5 cents to save $1. And so being able to point to success stories and where a really well-designed knowledge management program does allow you to work more effectively and therefore become a resource multiplier. And finally, don't forget number 1. Okay, Dean sort of, is a real Yogi Berra guy. I do like some of the Yogi Berra quotes, about, especially when you come to the fork, take it. But this one sort of talks about what leads to Granny's attic of knowledge management, I call it, or dumpster knowledge management. Just throw all this stuff in some sort of web-based thing, and then something good is going to happen. Like, huh? Or people who take a wiki before doing rapid business process analysis and just start throwing stuff on it, and it grows like Granny's attic. So it basically, to me, brings back and reinforces the point that you've got to know thy work process. You've got to go back and start with doing work. And Dave's far side, we should write that spot down. I guess. They apparently found the south underbelly of the package. And then something. So that's my story, and I'm sticking to it.
Question?
Sure.
Yeah, you center yourself around risk. You hear? Okay. You center yourself around risk. Now, we have an organization that we deal with process and hardware components. How do you facilitate people getting to these knowledge nuggets from the process point of view or from the hardware point of view as opposed from the risk point of view?
Well, indeed, if you're involved in AAA parts, huge risk right now to people in the aerospace industry is counterfeit parts. There's something called GUIDET. There's counterfeit parts. You guys, okay, again, start with what your work is. I mean, do you do supply chain management? Do you write specifications? Do you screw together hardware? Do you do hardware, software, test? Start with your work process. And that's why this model, I think, is so powerful. Because really, for me to give you a good answer to your question, I would take you through the 10 questions of rapid BPA. So I really understood what your work was. Then I could tell you, yeah, I'd stand up a wiki. I'd build a knowledge architecture that would have 6 bins. And then I would get subject matter experts and stakeholders to begin populating that. And then I'd set up a place where people could work collaboratively to author a document on parts risk management.
You selected that element to be risk, which is a different perspective than I've heard before.
Well, it is.
You got hardware, which not a lot of people like to rally around. You rally around process or hardware. But you're rallying around risk, which is a different perspective.
But it cuts across.
Yes, it does. It does cut across.
It cuts across human capital, hardware, software, test, verification, transportation and handling, operations. It's dealing with problems that need to be solved. If you want to go into a system engineering context, it's first cousin to failure modes effects analysis. If you want to go into system safety, it's first cousin to hazards analysis. It's simply asking throughout the program project lifecycle, what can go wrong, in what ways could it go wrong, and how could I control and or mitigate the probability of that problem happening. So it's very powerful in its simplicity.
You mentioned a little bit more, talked a little bit about the Riskapedia. Is there some functionality in that to allow for casual editing or
Oh, yeah. Yeah.
Discussion forums, threaded
Right.
type discussion?
Yeah, in fact, I've got a whole briefing on Riskapedia, but it begins with a narrative with 2 or 3 or 4 200-word narratives where we get a subject matter expert, let's say software verification, where I could get Mark Weatherall from, who's currently at the college where Jay used to work, to give me her best 200 words. And we found it very, very effective to take a rambling subject matter expert, literally rocket scientist, and say, no, I'm sorry, you got 200 words. Give me your best 200 words and the most important stuff I need to do to make sure the software and hardware work the way they're supposed to. And what we're trying to do is get several, and again, within the wiki environment, you can control access. We have provided maybe 3 or 4 subject matter experts that we call contributing editors to be able to add a narrative up front. The node will then have risk records associated with a given topic. It'll have good control and mitigation strategies. It will have links to space system failures associated with a particular discipline area. These are all things within the knowledge bundle. It's cool.
I assume that because you're using risk matrix, so consequence, is there a severe consequence with something, and is there a probability of it happening? That you can identify those critical risks to the program, and those are the ones you develop lessons learned and advice around.
Precisely. Precisely.
That gets a little bit back to your question, what are the few things I'm really concerned about? This allows you, and then you can matrix it in.
Also
The other side.
I'm thinking 5 years down the line too, that I got to come back and what did they really learn 5 years ago? And I'm approaching it from the hardware point of view as opposed to risk. How do I find it? It's a different, you have to be able to, it's three-dimensional. You have to be able to get to this information from your perspective as opposed to the perspective that you're presenting.
That's not the goal. It's not the purpose. If your activity is manufacturing, okay, in fact, there is a quality assurance node in Riskapedia that deals with quality assurance issues, supply chain management issues associated with hardware and software.
Okay, you are doing it. Just that I didn't capture that as of the presenting.
Okay. Well,
You're using risk across your processes, you're using risk across your programs, and you are using risk across your hardware as well.
Well, total. I mean, that's really, the central idea here is building rocket ships. It's hugely about hardware and software.
Yeah.
But it's also about organizations and human capital and resource planning and test and verification and systems engineering. All of that stuff has risk.
Okay, yeah, because what you presented were issues dealing with the program areas. You have these different program manager issues. As opposed to having to have a process person saying, hey, I don't care about that, I care about CFD, and I want to know my risk dealing with CFD.
Well, in fact, I would say right now the majority of the KBRs are associated with specific hardware issues. And the point I made is that one we're building right now is composite override pressure vessels, which is a huge, huge hardware safety issue and tough problem.